Our lesson today begins on page 23 in your notes package. We're going to look at a second way to solve exponential equations. If you recall from yesterday, sometimes when you have an exponential equation, you can make a common base. And if you're able to do that, then you just really can ignore those common bases and just deal with your exponents at the top to solve for x. But sometimes you have a situation like this, where you cannot make a common base. And in that case, this is a second way to solve exponential equations. So let's just make ourselves a note at the top of your page about that. Let's just say that this is often useful for solving exponential equations that can't be written with a common base. Okay, so make a note up here. Useful for solving exponential equations that can't be written with a common base. Okay, and then you'll need to find a highlighter, because I'd like you to highlight the statement at the top of the page. When that happens, when you can't write the exponential equation with a common base and solve it that way, then you know that this fact is true. If two expressions are equal, then the logarithms of those expressions are also equal. Okay, so what that means is, if 3 raised to the power of x is equal to 2 raised to the power 2, then the log of 3 raised to the power x is also equal to the log of 2 squared. Okay, so you just take the log of both sides. So I'll show you what that means. Okay, I've got 2 to the x equals 8. Well, this is a little bit of a poor example because you actually could make a common base because 8 is actually 2 cubed. But pretending that we can't do that, we're going to show you how to take the log of both sides as another way to solve this exponential equation. Okay, so if 2 to the x is equal to 8, then the log of 2 to the x is equal to the log of 8. Okay, now what I ultimately want to do is solve for x. So I need to try and isolate x. Over here in your margin, just put that your goal is to isolate x. Okay, that's what you're ultimately wanting to do whenever you solve for x. Okay, now in order to do that, I'm going to first of all use the power law of logs because I have x as my exponent. The power law is going to bring that x down and in front, isn't it? So really what this expression is x times log 2 equals log 8. Okay, now that I have it like this, it's going to be much easier to isolate my x. Okay, I would isolate my x by dividing this side by log 2 and dividing this side by log 2. So really, what I have left is x equals, on the left, log 8 over log 2 on the right. Okay, if you punch that into your calculator, log 8 divided by log 2, you're going to get that x equals 3. Okay, let's try the next one. 4 raised to the x equals 605. And I've played around in my calculator to see if 4 raised to some other exponent will equal 605 so that I can make a common base. I found that I can't make a common base because 4 raised to any exponent is not going to give me an answer of 605. So in that case I say, oh, well then the log of 4 raised to the x is equal to the log of 605. I just take the log of both sides of the equation. Okay, Again, I'm going to use the power law to bring the x down in front, so that's the same thing as x times the log of 4 equals the log of 605. Again, like I did before, I need to isolate my x, so I divide by log 4 on both sides, divide by log 4 on this side. So x equals log 605 divided by log 4, which is 4.62. I'm going to round it to 2 decimal places and leave it at that. Okay, that's pretty simple and straightforward, isn't it? Okay, let's try a couple more. 2 raised to the x equals 2500. So if that's the case, then I know also that the log of the left side is equal to the log of the right side. Again, I'm going to bring the x down front using the power law of logs. X times log 2 equals log of 2500. Then divide both sides by log 2 so that I can isolate my x. And x is log 2500 divided by log 2, which is 11.29. Okay, my next example says 8 times 3 raised to the 2x equals 568. Well, how is this one different from the other examples that I've done so far? Right, it's got this extra value of 8 out front here, okay? It's not just a straightforward 3 raised to the 2x equals 568 like all the other exponential equations have been. So really, I need to deal with this 8 first. So I'm going to divide that 8 out. But if I do it on one side, I have to do it on the other side to keep my equation balanced. When I do that, I have 3 raised to the 2x on the left side, and 568 divided by 8. If you plug that into your calculator, that's 71. Okay? Now I have 3 raised to the 2x equals 71. Now I just do what I did before. The log of the left side is going to equal the log of 71, the right side. Okay, again, I'm going to bring my 2x down using the power of logs. So 2x, the power law of logs, 2x times log 3 equals log 71. So again, I'm going to divide the left side by log 3, divide the right side by log 3. So then I will have on the left 2x equals log 71 divided by log 3 is 3.88. But I still haven't isolated x yet, so I need to divide both sides by 2, so x is 1.94. That's my final answer. All right. Next one. 5 raised to the power of x minus 3 equals 1700. Okay, well, this one is really no different either, except that this time my exponent is a binomial. It's x minus 3. But it's the same thing as before. I'm going to take the log of the left side. 5 raised to the x minus 3 equals the log of 1700. Okay, now I'm going to use the power law of logs to bring that x minus 3 down in front. So that's x minus 3 times log of 5 equals the log of 1700. Okay, then just like before, I need to keep my x on one side. So I'm going to divide both sides by log 5. Divide this side by log 5. So on this side, I will be left with x minus 3 equals, and on the right side, log 1700 divided by log 5 is 4.62. Now to solve for x, I have to add 3 to the left side, so I'm going to add 3 to the right side. 7.62 is what x equals. pretty simple and straightforward. I think you guys won't have any trouble with those. Just remember, if you have a situation where you cannot make a common base and solve your exponential equation that way, then just take the log of the left side and the log of the right side. Okay? Now, once in a while, you get a situation that is a little more complex to solve, and for some reason, this first step is on the bottom of my page 19. I think in your book, it should be at the top of the next page. At the top of page 20 is where you'll find this information. I'm not sure why mine didn't transfer properly to the smartboard, but we're going to learn about if you have a complex exponential equation, an equation like this where you have 3 to the x plus 7 equals 4 to the 3x plus 2, something like that, where again you can't make common bases, but you actually have binomial exponents on both sides, on the left side and the right side of your equation. They're a little more complex to solve, but we can solve them graphically using our graphing calculator, and it's really quite easy. The first step is you graph the left side, so this whole thing you would put into y1 on your calculator, and the right side you would put into y2 on your calculator, and it will graph both of those graphs. And then you just make sure that your window adjustment, you need to reset your window settings so that you can see both graphs and where they intersect. And that point of intersection, you're still trying to solve for x, so the x coordinate of that point of intersection is going to be the answer to this exponential equation. Okay, so I'll show you what that looks like, and we'll do some together here. So the first one we have is 4 raised to the 2x minus 1 equals 3 raised to the x plus 2. Okay, so in your calculator, you're going to go into your y1, and you're going to put the left side of that equation. So 4 raised to the, and then put brackets to keep 2x minus 1 as one value, 2x minus 1, and close your bracket. Okay, then go down to your y2 and put the right side of the equation in as your y2. 3 raised to the bracket again, x plus 2. Close your bracket. Now, it's always a good idea. I'm going to change my line to a thicker line just so that when I ask it to graph, I can actually see those two graphs a little bit easier and where they intersect. Okay, now at this point, you can see that I'm going to have to adjust my window. I think probably their point of intersection is going to be way up higher, so I'm going to have to play with my windows. It's my y maximum that I'm going to need to adjust. So y maximum, let's try going up to 100 and just see what that shows us and if we can see the point of intersection this time. Ooh, almost. Okay, I'm going to go in and maybe go up to 150 instead. And I don't think I need to see quite as wide on my x. So let's go up and change it just so that it will zoom in a little closer. I'm going to go just -5 as my x minimum and 5 as my x maximum. And instead of going up by 1, since I'm going from -10 to 150 on my y's, let's go up by 10s and just see if we have a little better view this time. We're looking for that point of intersection where these two graphs intersect. There we go. Now we can see it a little bit better, okay? So now what you do is you go in and you ask your calculator to calculate. So second trace will calculate the point of intersection. That's number 5. And remember with that, you just use your left and right arrows just to ride that little cursor around. and you want to go just as close as you can get to that point of intersection, and then you want to hit enter 3 times. And it will tell you that the point of intersection is at 2.14 for your x value and 94 for your 0.5 for your y value. Because you're trying to solve for x in this equation, it's the x value of that point of intersection that is your answer. So x equals 2.14. Okay, that's as simple as it is. You graph y1 as your left side of your equation, y2 as your right side of the equation. Ask your graph to calculate the point of intersection. Play around with your window a little bit so that you can actually see that point of intersection so that you can get the cursor there to calculate it. And then the x value is what x equals in your equation. Okay, so I would like you to try the remaining 3 on that page. So pause the video, do those 3, and then restart the video to check your work. Okay, the answers to the remaining 3 on that page are on the board, so just check your work and make sure that you got the same things that I did. And as long as you did, you're golden. So 2 different methods that we have learned to solve exponential equations. You can make a common base and then just solve the exponents at the top for x. Or if you have ones that you cannot make a common base, you take the log of the left side equals the log of the right side and solve for x. Actually, I guess, and a third way that we've learned is if it is a complex equation, you can enter your y1, the left side of your equation, and the right side of your equation into your y2, find the point of intersection, and the x coordinate of that point of intersection is what x equals. So 3 different methods we've learned for solving exponential equations. Mrs. Vartstra will have a handout for you today so that you can practice solving exponential equations using any of those 3 methods, just so that you get a little bit more practice with that. And then I also have for you today a review package that I'm going to give you that reviews the whole course. It has important notes in the margin, in the gray margins for you, just kind of the highlights or the most important things to remember from each unit, and then also some practice problems for you to work through. And I would recommend that over the Christmas break you spend some time reviewing some of the units, particularly the first 3 or 4 units that we did earlier in the year that aren't as fresh in our memories, so that when you come back in January and we dive right into finishing our exponents unit and then into our last unit, you will be well on your way for reviewing and have some time over the Christmas break to do that. So Merry Christmas to you. I wish that I had seen you today, but I hope you have a fabulous break and just a rest with your family and your friends, and we'll see you in the new year.